So we're looking at u plus v, pretty straightforward. 2u minus 3v, pretty straightforward. Cool. 3 times, so magnitude of 3 times u, that would be the magnitude of u. U is the vector. Then 1, 3, 4. Magnitude would be 1 plus 9 plus 16, which is square root of 26, right? So 3 times that would be root 3 of 26. I'll get on the magnitude, 3 times the magnitude.
And you'll get the same answer if you multiply it first and then...
Yes, good question. If I did, technically that's what you're supposed to do, right?
Okay.
This is the order presented, 3 times u. But what I did is I said, hey, it's a constant. That can come out. This is a rule you can use. You're allowed to pull a constant out. Cool? That's allowed. Okay. The next one was uvec plus vec minus uvec minus vec. Your answer should be not 0, but the 0 vector. So when you see uvec plus vec minus vec, this question was really just so that you would make sure to write hold 0, or you could say the 0 vector, whatever you want to do. Make sure you say the 0 vector again, because Kieran likes to write those true or false questions. Hi, if you're watching at home. My head's going to be above the camera for most of this. The 0 vector, so u plus v minus v would just give you the 0 vector, and he'll try and trick you on this sort of thing. I'll keep pointing out times where he'll try and trick you. You guys might remember the formula for the sine formula involving the cross product. Sine theta equals, don't write this down, uvec cross vec over magnitude of uvec times magnitude of vec. All familiar? What's missing? What's wrong? Why is this wrong? It needs to be a magnitude up here, right? So he'll deliberately drop that just to make it something false. He'll do that to you, right? Okay. What else was there? We were looking at u plus 3i minus 4j plus 5k. This was to introduce the idea that the ijk notation, that if you're talking about a vector u, which is 3, 5, or not 3, 5, 2, but rather negative 1, 3, 4, and I say plus 3k, or sorry, 3i minus 4j plus 5k, that's the same thing as adding this vector. Doesn't really matter that I called it ijk or 3, negative 4, 5. This would give us 2, negative 1, 9. Pretty straightforward? Good. Alright. Lastly, determine a vector that is in the same direction. You can write like that too, yeah? Smart. Lastly, determine a vector that is in the same direction as v, but has a magnitude of 1. What would that, let's just do this. Any idea how we should do that?
Unit vector?
Yeah, make it a unit vector. We call this type of vector a unit vector. So we're going to take the vector v and divide by its magnitude. Vector v is what? 4, negative 2, 2? 4, 2, negative 2. Its magnitude is square root of 16 plus 4 plus 4, which is square root of 24, better known as 2 root 6. So we're going to divide this guy by 2 root 6. You can leave it like that. You could divide the factor of 2 into this to get 2 over root 6, comma, 1 over root 6, comma, negative 1 over root 6, if you so choose. You could even rationalize, but nah, we don't care to do that. Cool? You're gonna head out? Alright, cool. This will be online later for you to watch, so.
And I don't have a lot of cash, but...
Oh, thank you. Yes, no, it's fine. Again, donations accepted and not necessary. Thank you. Yeah.
Hello.
So yeah, alright, dot product stuff. So I got a page on the dot product, a few applications of it, and then we're gonna do cross product and a few applications of that. The really important things, you might want to box this thing at the top. All these rules about the dot product you need to know. I think the first one is what happens when you dot the vector by itself. No, sorry, it's commutative. Commutative is to say that u dot is the same thing as b dot u. Switching the order doesn't matter, just like multiplication. Like you do 3 times 5 or 5 times 3. It's commutative. That's one rule. Dotting a vector with itself gives you the square of its magnitude. So that is to say, u dot u is equal to the magnitude of u squared. Good? And the most important one, number 3 here, is this formula. U dot v is equal to a magnitude of u times magnitude of v cosine theta. You might also rewrite this in such a way as to isolate the cosine theta. That's also very common. You could say cosine theta. I always say the dot products over the product of the magnitudes. But these are interchangeable, right? Okay. We're going to use these in a few problems right now. Find the angle between the vectors 2, 2, 2, and 1, 2, 5. All right. Oh, actually, no. Wait. It says when is the right-hand side of the formula 0? This is a good question. When is the right-hand side of the formula given here equal to 0? When is this equal to 0? Well, we're going to assume that the two vectors we're dealing with are non-zero. That is to say, their magnitudes will not be 0. So these guys won't be 0. But when is cosine theta equal to 0? If theta is equal to what? Got to know your unit circle. Pi over 2. Pi over 2 or 90 degrees, which is to say the vectors would be perpendicular. So this would be vector u, and that would be vector v. This gives rise to the idea, this is something you could write underneath that. If u and v are orthogonal, perpendicular, normal, they all mean the same thing. And by the way, you're going to hear me say normal, you're going to hear me say orthogonal, you're going to hear me say perpendicular. They all mean the same thing, right? If u and v are orthogonal, then u dot v equals 0, the scalar 0. And you're going to see that quite a bit on the test. You might at least you'll probably be doing a dot product check to see if something's orthogonal, maybe twice, maybe 3 times on the exam. So keep in mind that this is a tool you're going to whip out on the exam like a switchblade, like in a fight. Okay. All right. So next one, the first question says, find the angle between 2, 2, 2 and 1, 2, 5. Yeah. So we know a formula that relates the vectors and the angle between them. So we're going to say cosine theta equals their dot product. I'm going to quickly dot these guys. Make sure I'm on camera here. Yeah, I'm good. 2, 2, 2 dotted with 1, 2, 5 gives me 2 plus 2, oh, sorry, 4. Great, multiplication's hard. 2 plus 4 plus 10. All over. By the way, here's a quick trick you guys can do without saving some time. If you're given the vector A, its magnitude is a root 3. Time saver. So this is magnitude 2 root 3. Magnitude of this guy would be 1 plus 4 is 5 plus 25 is 30. So square root 30. Notice root 3 and root 30 have a common factor of 3 that I'll pull out. So this is really 16 over 2. This is 2 times root 3 times root 3 times root 10, right? Root 3 times root 3 is 3 times 2 is 6. So I have 6 root 10, better known as 8 over 3 root 10. And again, we tend not to simplify, even though we, in pre-calc, what do we do the entire time? We rationalize. We make sure there wasn't a radical on the bottom. We don't give a shit about that anymore. No one cares. No one cares if you don't have a radical on the bottom. No one cares. We're going to leave it like that. That's fine. And then we're going to take the arc cosine of that. So theta equals arc cosine, or you could say cosine inverse, whatever you want to say. I just like arc cosine because it makes it seem cooler. Oh, what's this arc cosine thing you're doing? Cool. That's all there is to be to it. Something I want to mention, though. This is an acute angle. It could very well be the case that the vectors you're dealing with do this. And that would not be an acute angle. Obtuse. Yeah, it's an obtuse angle, right? So to make it, here's what would end up happening. Because it's an obtuse angle, this angle will be larger than 90 degrees. Almost the cosine of an angle that's larger than 90 degrees. Or what kind of result will you get when you plug in an angle that's larger than 90 degrees in cosine? It's going to be negative. So if you ever get a dot product that's negative here, it's telling you that you're dealing with an obtuse angle. So I can give you two vectors that form an obtuse angle. The dot product will be negative. If the vectors are acute, like this, then your dot product will be positive. So be on the lookout if ever they ask for an acute angle. Because if they ask you for an acute angle, someone's calling me but I can't answer. Sorry. If you form a dot product and that result is negative, then you're dealing with an obtuse angle. If you were asked to make it an acute angle, here's how you can do that. Suppose for a moment that when I did this dot product, I got a negative out, and it would be obtuse, right? But the problem says I want an acute angle. How do I make it obtuse? How do I make the obtuse angle an acute angle? Ditch the negative, right? So I don't know if you're watching that. That would be obtuse, right? Because you got a negative on the inside. Arc cosine of a negative number gives you an angle that's larger than 90 degrees. So how do I make it an acute angle? Ditch the negative. Or you could do another thing. You could do the following. You could take this and do pi minus that. Two ways you can do it. You can do arc cosine of the positive, or you can subtract this number from 180 or pi radians.
So if the dot product's positive, it's obtuse, negative obtuse, and then positive acute, and then if it's 0, it's orthogonal?
Yeah, exactly, right? Perfect. That makes sense, right? Positive is acute. We're talking about gator chomp here. orthogonal, we've got 90 degrees, and when it's 0, and then when it's negative, both branches into negative lane, then it's an obtuse angle. Alright. Next problem. So next problem today. We've got magnitude of u is 4, magnitude of v is 2, and u dot v is 3. Compute u minus 2v. Alright, this assumption on the top. Was it 4, 2, and 3?
Yeah.
And I want you to compute u minus 2v dotted with 2u plus 3v.
Yeah.
God, my memory's on par today. Alright. The dot product preserves the usual operation of distribution, not property of distribution that regular multiplication does. So when I do u minus 2v dotted with 2u plus 3v, just use regular distributive property. Like FOIL. Remember it's FOIL, right? Back in Algebra 1. So if we were to FOIL this out, you'd get 2u dot u. I wouldn't say 2u squared, I'd say u dot u. Plus 3u dot b. Minus 4 v dot u. Technically, you should say v dot u because that's the order in which they're being multiplied. We see a v here, then a u here, but we know that v dot u is the same thing as u dot b. We can interchange those in just a minute. And then we have minus 6 v dot b. Okay. U dot u is the magnitude of u squared. 3u dot v and minus 4u v dot u are the same, are almost the same thing. And this is minus 6 v squared. Again, this is just using those formulas that are at the top of this page. I'm using the fact that a vector dotted with itself is its magnitude squared, and that the dot product of two vectors is interchangeable. U dot v is the same thing as v dot u. Let's clean this up a little bit. We know the magnitude of u is 4, so squared would be 16. This would be 16 times 2 would be 32. This is 3u dot v minus 4u dot v. You can just plug 3 in for both of these, but this is really 3u dot v and 4u dot v. 3 minus 4 would be negative 1, so we have negative 1 of these. So we have a minus 3. They need to stop cackling over there. V, the magnitude of v is 2, squared is 4, times 6 is negative 24. So we have 32 minus 3 is 29. Minus 24 is going to be all 5. Good? Hey. Can you give Nick his... Oh, you're here. Can you give Nick... you can make Nick's packet? Because I only printed 5. I didn't know if so many people would show up. It's fine. I only have... That's the only other one I have.
We can share one.
Yeah, sure. Go nuts. Have fun. And I'm posting this online later. It's recording. So you'll see me wave to the camera. That's when you have arrived. And you can watch the beginning part. And then, that looks nice. Did Jordan do that? I never did that. That looks good. See, it's not so bad.
Not so bad.
Anyway. I mean, some people don't like Jordan, but he's okay. I'm sure I sucked, but I was probably stiff up there. Did not have my jokes. Wasn't a very good public speaker, but now I'm a little bit better. Somewhat better.
Use your jokes, though.
Yeah,
Worse than
that's true.
jokes.
Yeah. Okay, so we got this result is 5. I'll get on that result. Okay, let's look at another problem. Are the vectors negative 2, negative 4, 2, and 4, 8, 4, negative 4 rather, perpendicular or parallel? Well, a way to check to make sure two vectors are parallel is just to see if one's a scalar multiple of the other. So is there anything I can multiply the first vector, namely negative 2, negative 4, 2? Is there some number here that I can multiply this guy to get, was it 4, 8, negative 4?
Yeah.
Is there some number I can multiply this guy by? Is there, did I get this?
Negative 2.
Negative 2.
Oh, wait.
So we're good. Not negative 2 factorial, negative 2, right? Okay. So negative 2 is a number that I can multiply this guy by to get this. So they are parallel. Pretty easy to check, and you guys have a pretty good eye for that, right? You can just say, oh look, that number happens to be 3 times that number. Gee, I wonder if there's a scalar multiple here that's going to be useful. All right, it's pretty easy. How about the vectors? Same vector, negative 2, negative 4, 2, and 3, 1, 5.
Take the dot product.
Take the dot product. If the dot product is 0, you know they're perpendicular. So dot those suckers. Dot. Negative 2 times 3 is negative 6. Negative 4 times 1 is negative 4. 2 times 5 is 10. Sure enough, that's 0. The dot product of these two vectors are 0, therefore, or is 0. Therefore, these two vectors are perpendicular. Good. And lastly, oh, this is a great problem. I love these problems so much. These just like speak to my heart. Find the values of k so that the vectors 3k squared, comma 2, comma negative 1, and 1, comma 4k, comma 3 are orthogonal. So we're not checking to see that they're orthogonal. We're assuming these vectors are orthogonal. We're trying to find the values of k in such a way that they are orthogonal. 3k squared, negative 2, comma 1.
Yep.
And
We know
what?
it's 2, negative 1.
2, negative 1. And then what?
And then 1, 4k, 3.
So we want them to be orthogonal. We're going to assume that the dot product can be 0. We should crank out that dot. We had some technical difficulties, so you missed out on the first 15 minutes. Sorry. Hopefully it doesn't crash again, otherwise the people who aren't here should out of luck. Okay. I have to get that girl her money back. Alright, so we're done with that problem. We're done with like the derivation projection. You might also be asked for the what's called the orthogonal projection. So back to this diagram. This is the projection of u on v. Here's u. Here's v. Here's the shadow that u creates on v. Orth is this guy. So if you're asked for that, how would you get that? Well, it turns out this vector plus this vector equals u. That is to say, the projection of u onto v plus the orthogonal of u onto v is equal to u. So if you know u, and you know the projection of u onto v, then you could easily find the orthogonal by subtracting it. So I would write that down underneath that guy. Let me make sure I'm going to have enough memory. God, I hope so. Okay. Good. So the problem we're given is what's vector u? U is what?
Negative 1, 3, 4.
And v is?
4, 2, negative 2.
So we're just going to apply the formula. Well, everyone's the projection of u on v. So it's just a matter of doing u dot v. That would manage to v squared all times v. Let's go ahead and figure out what this number is going to be down below, or just not down below, on the here on the left. Let's do u dot v really quick. That would be negative 1 times 4, negative 4. 3 times 2 is 6. 4 times negative 2 is negative 8. All over, manage to v squared. That would be 16 plus 4 plus 4 is 24. That's just this guy in parentheses over here. By the way, look at our dot product. Negative 4 plus 6 minus 8. That's a negative number, isn't it? That means what angle, what kind of angle is formed between u and v? Remember? No, other way around.
Obtuse.
It's an obtuse angle. That is to say, u is pointing this way, v is pointing this way, right? And actually, look what happens. Look at our projection. Is it in the same direction as v, or the opposite direction? The opposite direction. Hence the negative number up there. Make sense? So we have negative 4 plus 6 is 2, minus 8 is negative 6. It's negative 6 over 24 times v, which is better known as negative 1/4 times v, which would be negative 1, negative 1/2, positive 1/2. That is the projection of u onto v. Good. It's just applying this formula here that I did that. All right, let's find the orthogonal of u onto v. Well, that would just be orth is equal to u minus the projection. Just by rewriting this guy. So I'm going to take u, which I know, and I'm going to subtract the projection that I just found. Negative 1 minus negative 1 is 0. 3 minus negative 1/2 is 7/2. 4 minus 1/2 is 7/2. So that's your orth. Good. All right. It could ask you for this guy, they could ask you for this guy, they could ask you for this guy. Be prepared for any of them, okay? And again, this is merely the length up to a negative number. So technically, the scale is the scalar projection here. This number would have been negative for this guy. But does that mean the length is negative? We don't say, hey man, hey Billy Bob, can you hand me negative 10 feet of that 2x4 over there? No, that doesn't make any sense, right? So you would have to take an absolute value. So if the length of a projection is the absolute value of that would be the length, right? Because the length can't be negative. So if that was a negative number, as it is in this case, negative 6, I'd have to take the magnitude of that, or the absolute value of that to get the length. All right, I'm done with that. I'm rambling at this point. Let's move on to work. If I have an object, and if I have a force acting on it, but that's acting over a displacement vector d, then in order to figure out the work done, that's simple. Might have been something different than what you learned in Physics 1, right? You probably learned where work equals force times distance, and that's it, right? So keep in mind that they ask you to find work, and they give you a force vector, and they give you a displacement vector. Got them, and you're done. In this case, we have the force vector is negative 1, 3, 4, and the displacement vector is 4, 2, negative 2. You might notice a theme here that I'm using the same vectors. The force vector was what? Negative 1, 3, 4. And the displacement vector was 4, 2, negative 2. If I dot these, I'll figure out my work. Negative 1 times 4 is negative 4. 3 times 2 is plus 6. 4 times negative 2 is negative 8, which gives me negative 6. Some of you, this might be a little bizarre. How can I have negative work? That's negative 6 joules. Why is it negative? How's that possible?
Is that refer to the direction?
Yeah, it's exactly referring to the direction. Yeah, this phone, when I'm pushing upward against gravity, I'm doing work on the phone, I suppose, because I'm pushing it up. But by letting it down, gravity's doing more of the work for me, so I'm doing negative work. Cool. So it's okay to get a negative here. Don't say, oh shit, did I do anything wrong? No, you didn't. It's fine. Okay. We'll forget one more question, then I'll stop the video and start back up again, just and I'll stitch it all together later. Instead, suppose the hand exerts a force of 50 newtons across a distance of 20 meters. Okay? It's telling you the force is 50 newtons. The magnitude of the displacement vector is 20. You're told the angle is 45 degrees. Well, shit, how do we figure out what the work is now? I wasn't given vectors, but I was given the magnitude and the angle between them. Is there a formula that I know that relates the dot product to the magnitude of the vectors and the angle between them? Yes, namely S dot D, which is work, is equal to also the magnitude of the force times the magnitude of the displacement cosine theta. So depending on what information you're given, whether it be vectors or whether it be information about the size of the vectors and the angle between them, you're going to want to use one formula or the other. In this case, I was given this information, which does me no good here on the left-hand side. But this information just works perfectly here on the right-hand side. So I'm going to say this would be 50 times 20 times cosine 45 degrees. Make sure you know your unit circle. Whether some of you don't. Cosine 45 degrees is root 2 over 2. This is going to be 1,000 times root 2 over 2, or 500 root 2 joules. I don't know if Kieran cares so much about the units or not. I don't think anyone's going to bust your balls if you don't write joules. Not all of us have taken physics, but I'm assuming most of you are or are going to get to it soon. Next page. What are we doing? Cross product now? Please, cross product? Yes. Okay, good. Okay. How do you guys feel about taking a cross product? If I give you two vectors, could you cross them pretty easily? Okay, good. We'll skip that process then. Things you need to know about it, the cross product is that it's anti-commutative. That is to say, u cross v is negative v cross u. It gives you the exact opposite result if you do the different order. It's like putting on your shoes and socks, right? You put on your socks first, and then you put on your shoes, you're gonna get laid. If you put on your shoes first, then you put on your socks, nothing's gonna happen. No girls are gonna talk to you. Okay? So it's anti-commutative. Exact opposite thing's gonna happen. Okay. When you cross the vector with itself, it returns the zero vector, so make sure it's a bold zero, or you can say zero vector, whatever you want to say, but make sure this is implied. Make sure your writing implies that it is a vector, not a number. Okay. Next thing, what are we gonna do? What's next? The formula U cross. We're at this guy. Yeah, I'll just write it, but make sure you know it. It's very similar to the cosine one. Anytime you're asked to find an angle between two vectors, I prefer the first one because dot products are easier to compute than cross products, right? Cross products take that a long, arduous process of setting up the determinant, drawing your diagonals, whatever method you prefer to use. Now, on the other hand, if it asks you for the sign of the angle between two vectors, you might want to start with this because it's already got the sign encoded. So it's of course, you could use the dot product one, but that gives you what? It gives you cosine. But if I gave you cosine, how would you then find sine? What's a way that you can relate sine to cosine? If I said the cosine of an angle was 2/3, what would the sine then be? How can I figure that out? What's up? It's a. If I know cosine, then I can get sine is equal to the square root of 1 minus cosine squared theta. Right? You know that relationship between sine and cosine. Sine squared plus cosine squared is 1. So I could solve for sine by doing 1 minus cosine squared of theta. Right? That's one way of doing it. Or again, you could just start with this instead of people are like, I'd rather not have to remember this because I'm sure I won't remember it in a few hours. So people just like to stick with this. But it's up to you. Okay. What else have I got? The value. Oh, this is great. I've got a vector u and a vector v. The parallelogram that's formed by translating the vector v along u to the end, and by translating the vector u along to the end of v, gives you a parallelogram. The area of this parallelogram is equal to the magnitude of u cross v. Cool. And lastly, the most important one, number 5, is that most importantly, the cross product of u cross v gives a vector that is perpendicular to both u and v. Very, very important. We'll see that a bit later. God, I hope I just didn't record over my dot product stuff. That'll be fine. I'm really watching this. I might have to get this review again tomorrow. Ah, damn it.
You can maybe just use your phone too, record off your phone just in case.
My little potato of a phone. Yeah.
Space.
I'm sure I'll just figure it out. I might have to download the bitrate. I guess that might be what my problem is. I probably might be recording it like Gravity, the movie Gravity style bitrate. I'm not trying to film that. I'm not trying to film something amazing here. Okay. All right. So find the vector perpendicular to both -1, 3, 4, and 4, 2, -2. Okay. I'll do a cross product real quick. I, J, K. -1, 3, 4, 4, 2, -2. This is how you set it up. Some of you actually recopied the I and J columns over here into the diagonal method. I just do what's called expansion by minors, and I made a joke something like, some of you can do diagonal, some of you can use expansion by minors. I fucking love minors. That was a joke. Anyway, I think I started that joke by saying I love fucking minors. I mean, oh wait, that's not right. Anyway, minors is pretty good. Here's how I do it. This is -6 minus 8 is -14i. 2 minus 16 is -12, it's plus 12j. -2 minus 12 is -14k. And that's the cross product you should get. Cool. And this vector would be perpendicular to the original two vectors u and v. You can actually check this. How can I check and verify this vector is indeed perpendicular to these two vectors?
Take dot product.
If I dot this with this, I should get 0. -14 times -1 is 14. Don't forget that number. 12 times 3 is 36. 14 plus... Shit. 14 plus 36. That's not good.
22.
The fuck's that up? 14 plus 36 is 50. But 4 times -14 is -48. It's close, but not quite. But dot this wrong. -6 minus 8. -6 minus 8. -14. Okay. So far so good. 2 minus 16 is -14. That makes it plus 14. There we go. I'm already tracking on. Oh, that's cool. -14, 14, -14. Alright, let's check that again. -1 times 14 is 14. 3 times 14 is 42. Plus 14 is 56. 4 times -14 is -56. 56 minus 56 is 0. So this is a vector that is perpendicular to the original 2. And in fact, any scalar multiple of this would be perpendicular. So I could say 14i minus 14j plus 14k Right? That's another set. That's another vector that's perpendicular to the original 2. I can even go with 1, -1, 1. Right? Everyone agree that this is basically parallel to that. Parallel to that. Good. All right. All happy with that? Compute the area of the triangle form of the vectors. These two vectors. Okay. Vector 1, vector 2. I know that the magnitude of this cross product, the magnitude of this guy, is equal to the area of the parallelogram. Okay? So what's the magnitude of this guy? Anyone tell me really quickly?
Wait, but there's a negative one.
Doesn't matter. Because you squared anyway, right? You can just square those. That's the magnitude of this guy. 14 root 3. How the hell did you do that? Just use that, right? Anytime you get a vector AAA, what's up? Yeah, well, oh, right. Probably should mention that. Right, because I forgot I botched that part of the video. Really quickly, in case you don't know that, so thanks, Tom. If you have a vector AAA, or it doesn't matter if you got a minus, plus or minus A, plus or minus A, plus or minus A, the magnitude of that vector is A root 3. Cool, brief aside. That makes this computation really quick. So it's 14 root 3. That is the area of the parallelogram. But we're curious to find the area of the what? Another fucking question, guys.
Triangle.
Triangle. So I want half that. So what's the area of the triangle?
7 root 3.
7 root 3. So this guy, 7 root 3. Good? Makes sense? I want the area of the triangle, you take half that magnitude. Don't forget that. I've seen too many people forget to take that factor of a half, but then got the question wrong. Okay.
Do I have both on the multiple choice?
Yeah, I'm sure they will. I'm sure they will have both answers on the choice, just domestically. If u cross v equals 3, then compute the magnitude of u plus 2v cross 2u minus 3v. Holy shit. Okay. This looks just like the dot problem one, though, right? It's gonna that preserves it preserves the property of distribution. Is it 2u plus 3v? Okay. 2u cross u plus 3 u cross v minus 4v cross u minus 6v cross v. And I want the magnitude of this at the very end. So, remember, what is u cross u?
0.
The 0 vector. There's a bold 0 there. V cross v also a 0 vector. Okay, so let's go away. And we have 3u cross v minus 4v cross u. This order actually matters now, because when I did u cross 3v, it's 3v, I got 3v cross v. Then here's v, then u, left to right. So it's going to be u, v cross u. So I'm going to switch this around. Plus 4u cross v is going to be 7u cross v. What is the magnitude of this guy? Well, the magnitude of this guy would just be 7 times whatever the magnitude of gave you of u cross v, which was 3. So this is going to be 21. Are all good with that? I gave you the magnitude of u cross v to be 3, so 7 times that must be 21. All right. Let's look at the next one. Evaluate. Oh my god, this is a great problem. God, I always say the best for last. Okay. U dot 4u cross 5v. Anyone want to take a guess? This is not based on any of the u and v I gave you in the beginning of the page or anything. These are 2 different vectors. I don't know what they are. Didn't tell you what u was. I didn't tell you what v was. But what would u dotted with 4u cross 5ev? Without any information, you probably think the answer is probably something special and tricky and something simple. Yes, it is. What would it be? Any ideas? 0. You're right. But why? That's a bigger question. Why is it 0?
You have to distribute them.
I don't think dot product distributes over a cross product.
I still got the right answer, Andrew.
Still got the right answer. Even if you can't distribute that, it's still got the right answer. Here's the deal. What do u and v give you? What does u cross v give you? U cross v gives you a vector that is what?
Perpendicular.
Perpendicular to what, though? You get like saying, what's the difference between a duck? A duck and what, right? What's the difference between a duck? What are you talking about? So, u cross v gives you a vector that's perpendicular. Perpendicular to what?
U and V.
U and v. This vector will be perpendicular to u and v, right? So he just said,
Dot product of
oh, you're fucking ruining it for everyone. Yes. U cross v gives you a vector that's perpendicular to both u and v. Now, if you dot a vector that's perpendicular to u, with u, sorry, you dot u with a vector that's perpendicular to u, you should get 0. Make sense? Because you're making those connections, right? This is hard to see though, because you had to think, Oh, right. The geometric significance of the cross product is that it gives you a normal vector. Okay. So, all right, we're back for the planes now. Planes that we're doing next. All right. This is actually a more general comment about planes and lines together. For planes, you need a point and a normal vector. I think that might be the first statement I make there. You need a point and a normal vector. Find the plane that passes through the point 2, -3, 1, and is normal to the vector 5, 7, -2. Let's figure out how to make an equation of a plane given a point and its normal vector. So the point it passes through. Point was what again? 2, -1. What was the normal vector?
5, 7, -2.
5, 7. So here's how you write the equation of the plane. 5 is 7 times something. That's 2 times something. The coefficients of the normal vector will form the coefficients of x, y, z. Okay? And the point we know it passes through is 2, -3, 1. So we're going to say -2 plus 3, careful with the opposite sign here, -1. So 2 means -2, -3 is +3, and then plus 1 here is -1 in there. And this is the equation of the plane. I'm not going to waste your time distributing the 5, distributing the 7, distributing the -2, but this is something that they could do to make the answer look more simplified. I could distribute the 5 across and then add the -10 over, 7 times 3, subtract the 21 over, -2 times -1 gives me a +2, subtract 2 over, so forth and so on. But the very least your answer should contain 5x plus 7y minus 2z. Something you could do to make it look tricky is say, if you didn't see your plane listed, you might also see 10x plus 14y minus 4z equals some number, whatever number you would get over here on the right-hand side. So this is indeed, will be parallel to this plane, right? Or it could very well be the same plane, just because I've multiplied everything by 2. So be on the lookout for that. It's kind of a dick move. That's me saying, what line passes through 1, 2, and 2, 4? Well, that would be the line y equals 2x, right? I plug in 1 for x, what do I get for y? 2. I plug in 2 for x, what do I get for y? 4, right? This is also equivalent to the same line, 3y equals 6x. Not that anyone insane would do that because they have a common factor of 2. I would divide through by 2. Why would I waste my time writing more constants than I have to? But this is something Karen will do to you guys, so be on the lookout for anything that looks suspiciously like a multiple of the normal vector you started with. Good? All right. The next one's 3 points given. Yes, 2, 3, 3. What are the points? 2, 3, 3.
1, 5, 1.
1, 5, 1.
4, 4, 4.
4, 4, 4. Now here I've given you 3 points from which to make what? 3 points can make how many vectors? 2. So what I tend to do is you can say initial, terminal, terminal in this thread, ITT, whatever. Or you could do, if you were, I don't know, feeling dirty, TIT, right? Or TTI, stuttering rapper. What's your name? TTI? Okay. I read from left to right, so this is my initial, this is my terminal, so I'm going to do terminal minus initial to get my vectors. Here's how I do this really quickly. Don't do 1, just do it in your head. To go from 2 to 1 in the x direction, how far would you have to go? Up 1 or down 1? To go from 2 to 1. Sorry, I'm speaking really fast. To go from 2 to 1, you're going down 1. 3 to 5. Up 2. 3 down to 1. -2. Alright, now we're going to do this guy, initial to this other terminal, starting at 2, 3, 3, ending at 4, 4, 4. I'll get the vector 2 to 4 is 2, 3 to 4 is 1, 3 to 4 is also 1. Notice how I'm stacking the vectors. I'm stacking the vectors because I know I'm going to have to do what with them anyway. So I'm going to have to cross them. Why doesn't it make my job easy? I've seen all too many people write the first vector, then the second vector. Oh shit, maybe I should stack them on top of each other from the get-go, and that way it makes my cross product come out pretty quick. I, J, K. 2 plus 2, 4, 4i, shit, -1, plus 4. -1 plus 3, minus 3. Okay. -1 minus 4, minus 5. Okay, that's my null vector. The question is then, again, this is my null vector. I want to do n hat to say, hey, got my normal vector, that's good. What else do I need to make a plane? I got a normal vector and a point. You have your veritable pick of the litter when it comes to points. Which one would you like to use? We'll use the first one. I read from left to right. That's your weird in Japanese. You read from some source back up top to bottom to top. Something like that. 2, 3, 3. So we're gonna say 4 x minus 2 plus, rather minus 3 times y minus 3, and then minus 5 times z minus 3. 0. About lines, I guess? Okay, good. Much the same way that for planes you needed a point and not a number vector, you need a point and a direction vector. Direction vector is not a technical term. You won't find it in any book. This is an Andrew Eleanor trademark term. Direction vector. This is just what I use to signify the slope of a line. Okay. So on problem 1, determine line 4, 1, 0, 2, negative 2, 3. We don't have any concept of slope anymore. You can't do, remember, slope is what? y2 minus y1 over x2 minus x1. We can't do that here. What would you do? Would it be z2 minus z1 over y2 minus y1? Would it be a big fraction bar? Would it be a small fraction bar? Do I do that? Or do I use that? X? I don't know what I would do. What would it be? Y then z then x? I don't know. So we can't use slope. Slope only works in 2 dimensions. So we have to use this idea called direction vector. Direction vector is the 3-dimensional analog of slope. That is to say, we don't use slope, use direction vector. So let's find the direction vector. To go from here to here would be this negative 2, negative 3, 3. This is basically, for all intents and purposes, your slope. This is essentially your slope. So you have a slope. What else do you need to make a line? You need a point and a slope. We've got our slope or our direction vector. We need a point. We have 2 points to choose from. I'm going to use this one, 4, 1, 0. So there's several ways you can write the equation of a line. We'll start with the first one called parametric form. When you write in parametric form, what you do is you write the point 4, 1, 0 or 1, 0. And then you say plus the direction vector times t. So we have minus 2t for the x component, the minus 3t for the y component, plus 3t for the z component, and that's it. A few things I want to say about this. Again, this is what's called the parametric form. There's also 2 other forms you might be expected to write it in, which we'll get to in a second. What happens when I plug in 0 for t? What do I get? I get, for all 3.
X equals 4, Y equals 1.
Get 4, 1, 0, right? Basically, if I let t equal 0, I get that point. When I let t equals 1, I get 4 minus 2 is 2. 1 minus 3 is negative 2. 0 plus 3 is 3. So by letting t equal 0, I get the initial point. By letting t equals 1, I get the terminal point. Cool? In fact, he might ask you to construct a line segment, in which case what you just do is the same thing, but you say, that's what makes a line segment, is that the only difference between this and the entire line is placing a restriction on t. So this gives me a line segment, but if I don't have that, it's understood that t is anything it wants to be. It could be a negative number, it could be a small number, it could be 0.5, any number you can think of. What's another point that's on the line? Pick a number, pick a value for t other than 0 or 1. 4. 4? 4, sure. I lost the cap. 4. Well, let x equal, or t equals 4, I get x equals 4 minus 2 times 4 is negative 4. 1 minus 12 is going to be negative 11. Z equals 12. This is another point that is on the line that corresponds to t equals 4. Okay? I could ask you, is the coordinate is 0, negative 5, negative 6 on the line? How would I verify that? What I'm going to do is I'm going to figure out what value of t would cause 4 minus 2t to equal 0. For what value of t would 4 minus 2t equal 0? 2. Yeah, 4 minus 2t equals 0, 4t equals 2. So when I take t equals 2 and plug it into this, I better damn well get 0, negative 5, negative 6. And if I don't, this point is not on the line. So let's do it together. 2 times 2 is 4. 4 minus 4 is indeed 0. We already did that. Knew that was going to happen. Negative 3 times 2 is negative 6. What's 1 minus 6? 2 times 3 is, which does not match that. So no, this is not on the line. It makes sense. Did you get that? You got that? Got that? Got that? Okay. Okay, symmetric form. You could write it in vector form. Vector form is just the following. You could say R, you would say R of t equals this guy, Y component, Z component. That would be vector form.
Alright, so what were the
Pretty obvious.
matrix?
Symmetric form is where you solve for t in each of these components. Solve for t here. If I solve for t, I would get x minus 4 over negative 2 equals t. I would also get y minus 1 over negative 3 equals t. Now we'd get z divided by 3 equals t. Now because each of these equations equals t, they all equal each other. This is what's called the symmetric form of the line. So in order to find the symmetric form, you take the parametric form, solve for t in each equation. And because they will all equal t, they will all equal each other. Good on that. And if you notice closely, you can look closely and see what the point that the line contains, 4, 1, 0. Right? And the direction vector, -2, -3, 3. So that's how you can read the symmetric form. Be very careful though, because I could do this. X minus 4 over -2 can be rewritten as 4 minus x over 2. And to the untrained eye, what do people read the direction vector as? 2, -3, 3. When you really should be reading it as what? -2. Does that make sense? Here's an even trickier way I can write this.
So pretty much we're saying this is a scale.
What does it look like the direction vector is? 2, -3, 6. It's got to be -2, -3. I can simplify that. Make sense? So -2, -3, 3. Here's another way I can mess things up. I can't simplify that, can I? 2z over 3 doesn't simplify. So really, but I could say this is, how can I rewrite this in such a way that I have a coefficient of 1 on z? A 2 in the numerator is the same as a 2 in the denominator of the denominator. That would flip and multiply, right? So this is really 3 halves. Cool? So keep that in mind. You have to make sure that the coefficients up here are all positive 1. This is currently a -1, so you make sure to say negative there. This would have been a 2, so you put the 2 down on the denominator, stuff like that. We'll keep going. More on lines. Find the equation line is parallel to. Here's another one. Here's I've given you the symmetric form. X minus 2 over 4. 2y minus 8. And 2 minus z over 3. So we're going to put that what I said earlier to use. What is the direction vector here? 4. Careful. 2y minus 8 is not maybe not the best way to write that. We want the coefficient y to be 1. So we're gonna factor out a 2. Factoring out a 2 there and putting 1 on the bottom. A 1. Does that make sense? Tricky, right? Messing with your head a little bit. And then so we have 4 1/2. What's our z component of our direction vector? -3. What's the point on the line? Or it was given a point, right? 1, 2, -3. So to write this in parametric form, I'm going to say x equals y equals z. 1 plus 4t. 1/2. 2 plus 1/2 t. And -3 minus 3t. That's your parametric form of the line. And you can write it in symmetric if you solve for t and so forth and so on. Okay? Alright. At which coordinate does the line given by blah intersect the plane? Oh, that's good. Okay, so here, what I'm going to do is, given this equation, it's y plus 3 z minus 1 over 2. When does this guy intersect the plane given by 3x minus 2y plus 1? We're going to revert this back to parametric form. So it's currently in symmetric form. How did we get to symmetric form, parametric form? We had set all these equal to what? To t. So say e plus t. I'm going to solve for t in each of these. Or solve for x. Solve for x here, excuse me. X equals 4t plus 2. Y equals t minus 3. And z equals 2t plus 1. But now that I have an equation for each x, y, and z, I'm going to take these guys. I'm going to get 3 times 4t plus 2 minus 2 times t minus 3 plus, oops, plus 2t plus 1 equals 3. Want to multiply this out and figure out what the values for t are.
So it's a for some reason when I use my calculator, I try to find out how value is 10 negative 5 negative 5 10.
And the question asks you, what point does this line intersect that plane?
Yeah.
That's not an answer. First of all, why is that not an answer? It's not a what? It's not a point. It's a parameter t that describes a point. So in order to figure out what that point would be, I would take negative 5, 6,
Alright, so
plot it up into there, and whatever point I would get is my answer. So I would take this, plug it in for t, that would give me coordinate negative 5, 6 times 4 would be negative 10 thirds plus 2 would be negative 4 thirds.
so
Negative 5, 6 minus 3 would be negative
minus 5
negative 23 over 6.
lambda 1.
And then negative 5 thirds plus 1 would be negative 2 thirds. That would be the coordinate. That plane, and you can check to make sure to take that and plug it in there, make sure it actually satisfies the plane. That would be the point for which that plane intersects that plane. It's a lot of work there. We'll do this last question, take a break.